Unit 2, Part 2 review. What we'll review here is the quadratic formula, completing the square, how to find the discriminant, simplifying expressions involving complex numbers, how to find the zeros by knowing one factor or by first finding the zero in the calculator, the sum and product theorem for complex roots, and how to write an equation for a polynomial. First, we have the quadratic formula. And the standard formula for that is ax squared plus bx plus c equals 0, in which a, b, and c are variables, and x is the unknown. The quadratic formula is x equals negative b plus minus square root of b squared minus 4ac all over 2a. The formula for completing the square is c equals b over 2 all of that squared. And here are two examples, which you can pause the video and try. And here are the solutions to the two examples. So I'll go through the first one. It's x squared minus 12x plus 5 equals 0. What you do first is subtract the 5 and move it to the other side. So you get x squared minus 12x equals negative 5. And then you can use the formula c equals b over 2 all of it squared, and negative 12 is your b. So you get negative 6 squared, which is 36, which you add to this side, so you get x squared minus 12x plus 36, and then you add it to the other side as well, so it cancels, equals negative 5 plus 36. When you factor that, you get x minus 6, all of it squared, equals negative 5 plus 36, which is x minus 6 all squared equals 31. And then you take the square root of both sides, so you get x minus 6 equals square root of 31, or positive plus minus square root of 31. And your x is 6 plus minus square root of 31. And the same thing goes for the second one. Next we have the discriminant, which is the b squared minus 4ac part of the quadratic formula. How you find the discriminant is we have an example. So the example is x squared minus 11x plus 10 equals 0. So since 11x is your b, you just take it and you do negative 11, all of it squared, minus 4 times 1, which is the a, times 10, which is the c. Negative 11 squared is 121, minus 4 times 1 times 10 is 40. So 121 minus 40 equals 81, which is your discriminant. And the discriminant helps you find the different solutions. So since 81 was a positive square number, you get two real solutions, which are 9 and x equals 9 and negative 9. If the discriminant equals 0, you'll only get one real solution, and if the discriminant is a negative number, you get no real solutions or two imaginary solutions. Next we have complex numbers, which goes from the imaginary solutions. So imaginary numbers are complex numbers, and the main one that we know is I, which equals square root of negative 1. You can simplify with complex numbers, with imaginary numbers. So square root of negative 4, we can find what that is and simplify it. Square root of negative 4 is actually I, since I is negative 1. So it's square root of negative 1 times square root of 4, which is I times square root of 4, which is 2I, because square root of 4 is 2. And then finding complex numbers in the form of a plus bi is where a and b are, where a is the real number and b is the imaginary number, such as this.
Complex numbers continued. So here's a, it's square root negative 9 plus 6. First you take out the I, or take out the negative, which gives you I at the end of square root 9. And then, so you have square root negative 1, which is I, times square root 9, which is 3. And you leave the 6, so you have 6 plus 3i. And then same goes for the b. Here's how you add complex numbers. You just add across. So you see 5 plus 7i plus negative 2 plus 6i. So you add across, get 5 plus negative 2 equals 3. And 7i plus 6i equals 13i. Multiplying, you multiply regularly and FOIL. So 5i times negative 4i gets you negative 20i squared. So then you take I squared is the square root of negative 1 squared, which ultimately gives you negative 1. So you have negative 20 times negative 1, and your final answer is 20. For subtracting, it's the same as adding, just across. So you have 8 plus 3i minus 2 plus 4i. 8 minus 2 equals 6. And 3i minus 4i is negative 1i, so you have 6 minus I. Dividing is you take the reciprocal of the denominator and multiply it by both sides. So if you're multiplying across, 6 minus 5i times 4 plus 3i, you end up with 24 plus 18i minus 20i plus 15. And then the bottom is 4 minus 3i times 4 plus 3i, and you get 16 minus 9i. And if you simple the numerator and denominator, end up with 39 minus 2i over 16 plus 9, which ultimately gives you 39 minus 2i over 25. For finding zeros, one way to find a zero is synthetic division. That's where you take the coefficient of each number and the factor and write the coefficients out, bring down the first one. So you bring down 1, multiply that by 3. So you put that next to the bottom under the negative 12, then add those, and then you keep repeating that process. So and you get your coefficients, and you take off one power. So you get x squared minus 9x plus 20, and you factor that into x minus 5 and x minus 4. So your final answers are 5, 4, and you get 3 from the factor up top they give you. Here's one more to try. Use the same process. Another way to find zeros is through the quadratic formula like we talked earlier, where you just plug in the values and then solve. So for this one, it's 3x cubed minus 8x squared minus 4x. So you plug in all those values to there. So you get 8 plus or minus square root 64 minus 4 times 1 times negative 4. And then you break it up into those below and solve. So you get 2 plus or minus square root 16, which ends up being 2 plus or minus 4 over 2. And that equals 1 plus or minus 2. And then another way, yeah, that's it.
Okay, you can also find zeros in the calculator by putting the entire equation into the y equals and then graphing it and finding where it intersects the x-axis. Then you use that and put that in synthetic division. So our x-axis intersection was 3, and so you put 3 over here because that's what x equals, and then you use synthetic division and drop it down and then solve it out, and you end up getting everything down from this equation. You get x squared minus 9, and then you can factor that out into this and get 3 or negative 3. Sum product rule is when you have the equation and you have it and you put it in x squared minus the sum x plus the product. You use to find the equation of a polynomial. So if you're given the root 3 plus 2i, you're also given 3 minus 2i. So then you can add those together to get the sum of 6, and then multiply them out to get the product of 13, and then you put it in the equation. So it's x squared minus 6, because it's always minus, don't forget that, because this is the sum, and so you get x squared minus 6x plus 13, which is your product. Writing an equation for a polynomial. If you're given rational and imaginary roots like 2 plus 4i and 5, you can make an equation from there. First, identify your roots, which are 2 plus 4i, which gives you 2 minus 4i, and 5. Then use the sum product rule as shown below, or as shown above. You add those to get the sum of 4, and the product is 20, or 16, or 20. And then You put that in the equation, but you still need this 5. So you add, or you multiply the 5, and then that gives you this. So now you can try these. Factor and find the zeros of each equation. And not number 3. And here are the answers. Good luck!